This video we're gonna look at an example of a couple, and all we're gonna do is to calculate the equivalent moment that those two forces create in a rigid body. And the reason we want to do that is we can replace those two forces with that moment, and we can actually put that moment anywhere in that rigid body, and that's going to help us with some calculations later on. So let's look at the example. So let's say that for this example, and it's for example, this is couples, right? We're gonna say that we have, let's continue with our idea of a being, right? That is someone fixed on a wall, and let's say that we have two forces. We're gonna have a force applied here, and the angle of that force with the vertical is, let's say, 40 degrees. And let's say that the magnitude of that force is 100 pounds. We have a second force somewhere in here, which is also 100 pounds, and it is also 40 degrees from the vertical. So these two forces create a couple, right? All right. Now, to calculate the moment created by this couple, and that's the objective of the this example, right? Calculate moment produced by the couple. And to be able to do that, as we saw in the previous video, I was talking about the perpendicular distance between the forces, and we can do that. We can calculate this distance over here. We're gonna tell you a different way in which we can do that. And what I'm gonna do is gonna take these forces, and I'm gonna decompose those forces in two forces, one along the x-axis, one along my y-axis, or horizontally and vertically. I need to add axis to this. And then what we're gonna see is that those along the horizontal line will not create any moments because their line of action is the same. But those vertically are going to create a moment, and we will know the distance between those two. Let's say that this distance, let's say it is 3 feet. Okay. All right, so what do I mean by that? Okay, let me take this 100-pound force. What we're gonna do is decompose it into two components. So let's say that this is my 100-pound force. I'm gonna put my y-axis in that direction, x-axis in this direction. We know that this is 40 degrees. And basically, what I want to do is find this force. Let's call this F1y, and this force F1x. So if I find those two forces, I should be able to simplify the problem a little bit. There's one way to simplify the problem. Okay. All right, so how do I do that? I have my angle over here. I have my magnitude. So we know that my F1x is going to be 100 sine of 40 degrees. And my F1y is going to be 100 cosine of 40 degrees. So I'll punch that in my calculator. For the first one, we have 64 64.28 pounds. And for this one, we have sine 76.60 pounds in the y direction. Okay, very good. So now that we have that, basically I can replace that image that I have on top with the components, right? So I'm gonna redraw that rigid body. I'm just gonna add the components, okay? So what I have here is the same rigid body. This is my wall. This is my beam. And in this location where we have the first force, what I'm going to do is put those two components. So over here I have a force of 76.6 pounds. And I also have another force in this direction. I'm going to change the color so we can see it. The magnitude of that force is 64.28 pounds. Okay. All right. Now I have two more forces, right? The other two forces that replace the force here on the right hand side. And what I'm gonna do is I'm also gonna put the components. I don't have to redo my calculations because I know that the magnitudes are the same that we calculated before. The direction is gonna be opposite, but so when I come, those calculations work. So when I go over here, I know that I have a force in this direction, and the magnitude of that force is 64.28 pounds. And now I have another force this direction. I should have done that white so we can match things. And that is 76.60 pounds. All right, so let's look at this for a second. And what I see is that these two forces, the ones that are in yellow, are not creating any moments in that rigid body because they are in the same line of action, right? So there is no perpendicular distance between them. But these white forces that we have over here are creating a moment because they have a distance between them. And that distance, based on the problem statement, was 3 feet. So my moment is going to be equal to, first I need to define the sign. There's going to be a positive moment based on my right hand rule, so plus my force times my perpendicular distance, so it's 76.6 times 3, and that gives me 230 pounds foot. That will be my answer, right? 330 pounds foot. So that is the moment that that couple is creating. Now, let me ask you to do something to see what do you get. What if you calculate the moment of those two forces and add it together on a point somewhere else? Let's say a meter to the right, or a foot to the right of your of this force. So calculate the moment of that about this point, the moment of this force about that point, add them together and see what you get. Regardless of the point that you use, you should obtain exactly the same answer, right? And what that really is telling us is that we can really take this moment that is created by that couple and apply it anywhere on our rigid body.